You practice this question.
No, sir, I didn't. Yes.
Yeah, but whenever you get time, please, this is very important. That will clear your idea of KVL and all those junctions, right?
Yes,
So
sir.
please do this question. Please practice this question, right? And whenever you have practiced it and then you face any problem, then ask, right? Because I want you to solve this question. Don't look at those answers. Just try to utilize or just try to apply those loop rule, and then ultimately you will get the result, right? You need three equations. You have three unknowns, I1, I2, I3. You need three equations, and then you use a loop rule in all these three loops. Then you will get three equations, solve those three equations, and then you'll get your answer. But I want you to solve this equations. Please do that. And today we'll start the new chapter, which is that is magnetic magnetic
Yes.
moving charges and magnet. First thing that we have to talk about is the obviously the magnetic field, right? Yeah. So the first topic is related to bio David's right. First topic. To reach here, first we'll understand what is the magnetic field, what is the magnetic field strength, magnetic field intensity, and what kind of quantity is magnetic field and how it arises. So all these things we will understand, and then we'll talk about this Biot-Savart's law, right? So in this class, I want to at least complete this Biot-Savart's law and then Ampere's circuit law. So I want to cover all those topics. So first thing is what is magnetic field, right? So
Yes.
we saw in the previous chapters, right? We saw that we had these charges which were stationary, and then in the third chapter we saw that we have a charge which is flowing in a conductor, right? So charge is flowing in a conductor that creates the magnetic field, right? So what is this magnetic field? So what is magnetic? And if we have done already the all those chapters of electric charges and fields and all those topics we have covered already, so we will always take the analogy from those chapters. So what was the electric field? What was the electric field? Do you
So
remember?
you're asking the definition for
Yeah,
electric
yeah,
field?
yeah. What was the electric field? What is the definition for the electric?
So an electric field is it's essentially like the force per unit charge, like in a certain area. It
Yeah,
is the
so force per unit charge, not in an area, but force per unit charge in everywhere, right? But yeah, electric field. What is that? So that is the mathematical description of that, right?
Okay, fine. So the electric field is simply speaking, it's just a region of space or a
Yeah,
field
yeah,
in which an electric charge will experience a force.
yeah. So that is yes, absolutely correct. So you have a charge and the region around that charge in which you can experience the Coulomb forces. So that would be called the electric field. So similarly, the regions around the magnetic materials in which we can experience its magnetic effect, right? So that would be called the magnetic field. So that is the definition of this magnetic field, right? So the region or the regions around the magnetic material in which one can experience the magnetic effect is called the magnetic right? And it is represented by B, right? It is represented by B. And this magnetic field, it is a vector quantity, right? So we have to be very careful with the addition, subtraction of these magnetic fields, right? It is a vector quantity. Its SI unit is Tesla, right? It's which is represented by which is by T, and its CGS unit is Gauss, right? Where 1 Tesla is 10 to the power 4 Gauss, right? So this is the CGS unit, and the cause of this B is actually whenever they tell you that this B is actually the magnetic field strength or intensity, magnetic field intensity. But conventionally, to match this electric field, it is called magnetic field, right? But conventionally, it is called magnetic, right? So, what are the causes of this magnetic field? So, the cause of this magnetic field, can you tell me the cause of this magnetic field? So, the magnetic field arises due to current in conductors, right? So, this is the
Yes.
cause of, and then you have these magnets also. So, the polarity of those magnetic materials also causes this magnetic, right? So they also carry these magnetic fields. So these are the two main causes of the magnetic fields. And then how do we calculate this magnetic field, right? So let's say we want to calculate the magnetic field of current carrying wire. So this is given by Bio-Savart's law. Bio-Savart's so from Bio-Savart's law, we calculate the magnetic field flowing through a current carrying wire. So let's say we have this current which is flowing through this wire, right? And the current which is flowing is I, and I take a small length element, right? I take a very small length element. I will take a very small portion dl. So its direction would be this, right? And then I want to calculate the magnetic field at this P point, right? So the distance between this length element and this P point is, let's say, R vector, right? So that is R vector. So the magnitude of the distance between these 2 points is, let's say, if I represent only the magnitude, so that is R. So what does this Biot-Savart's law states, right? So let's say this is theta. So the angle between dl and this R. So what do we have? We have dl. This is the small length element of the wire, right? And then I have this R. This is the distance between dl and the point where calculate the magnetic right? And then this I is the current flowing in the wire. And then the theta. This theta is the angle between dl and r. So this is very so these are the things that we are focusing on, right? And let's say at this P point, we are calculating the magnetic field. PP is the magnetic field at P point. So what does this Biot-Savart's law states? It states that the small magnetic field, right? So small magnetic field at this P point, that would be directly proportional to the current. That would be again directly proportional. This is a dB, right? This is the differential operator that you have. So dB is the small magnetic field. So I can write this as delta B as well, right? So dB is a small magnetic field at this P point. So this dB is also directly proportional to this length element dl, and then this dB is also proportional to the sine of the angle of the theta, and then lastly dB is inversely proportional to r square, right? So then if we collect all these things, so what we will get? Small magnetic field at P point that is directly proportional to pi dl sine theta divided by r square. So if we remove the proportionality, right? If we remove the proportionality, then some proportionality constant would be there, right? So if we remove the proportionality, so then we have some proportionality constant, and that proportionality constant is this one. So this we get from the experiments, and then this is the form that we get finally, right? So this is called the biosavers. And if we compare it with the electric charge, we take the analogy. So do you remember what was the electric field? That was 1 by 4 pi epsilon naught and q by r square, right? So that was the electric field, and we see that the variation is quite similar, right? So this is 1 over r square, that is also proportional to q, and this is the electric. So we will always take the analogy. So this is Biot-Savart's law. And did we talk about any direction in here? Did we talk about any direction in here? Is this a vectorial quantity? Yes.
No, sir.
No, because we don't have any direction. We have not talked about the direction at this point at all. So this is a directionless quantity, right? As of now. So that we will call as a scalar form. So we are only talking about the magnitudes. So magnitudes. What if we write it in vector form, right? So if we write it in vector form, so this is given by mu naught by 4 pi and I d l cross r divided by this r cube, and this is the vector, right? This is the vector form. And remember, what kind of product is this TL cross R? What kind of product is this? Yes, what kind of product is this?
Sir,
TL cross R.
yes.
The name itself has an answer, right? TL cross R. So what kind of product is that?
Sir, can you say it out a bit loud?
Yeah, so I'm telling that TL cross R. What
Hmm.
kind of product is this? The answer lies in your question. What kind of product is DL cross R?
What kind of product is here? So,
So when we are talking
sir,
about vector,
cross product.
absolutely right. So that was already there in the question, right?
Yes, I was thinking.
So cross product. So and we already know that cross product is what kind of product?
So, cross product is what kind of
Yeah. So
product?
in a cross product, the answer that we get is also what? You
So,
have
it's a
to,
vector product.
yeah, yeah. It's yeah. So that is yeah, that I was. So it's a vector product, right?
Hmm.
So, so this dl cross r would be a vector quantity, right? Which will have some direction. So then we will get this magnetic field as the vector. So that is how we get the magnetic field in the vector form. So this contains the magnitude as well as the direction. But this part only contains the magnitude, right? So you note down up to this point, and then we'll talk about how do we calculate, how do we figure out the direction of this magnetic, because we can easily calculate the magnitude, but we also have to look for the direction because this magnetic field is a vector quantity, right? So that yeah, that we'll talk about in a moment, but you note down up to this. Yeah, whenever you want me to scroll down, please that. And B is not coming, right? That's it. Is same as B.
Yes, sir. Sir, if it is it possible that we can end the class early, like maybe 10 minutes early?
10 minutes early, yeah. 10 minutes early we can.
Okay, sir. Because I'm done mostly with the literature part of English. I didn't start with the writing part and all, right? Like
Yeah,
letter
yeah, yeah.
writing, notice writing, and all that.
Oh, yeah. So format, yeah, you have to remember all those formats, right? Format for formal
Yes,
letters, format.
I have to. I asked the teacher. She just said practice that from the skill book and all. That's because on the internet I searched, right, and there's very different formats from the
Yeah, yeah,
school
yeah.
textbook. That's
So
why.
don't rely on those internets, right? Because all these have different. You have British English, you have
Yes, sir.
American English, so all those have different formats, right? And then you
Mm.
have those old books, and then you have these new books. So all these have changed times. In my earlier
Yes, sir.
days, the format of letters were different, and nowadays it is totally different. So always stick to your teachers, right?
Yes, sir.
Don't look at this internet.
Yes, sir. I'm done. Can you scroll down?
Yeah. So and did you start your revision?
Yes, sir.
Yeah. So take out 3 hours of yours daily and start your revision, right? So that you can complete all your chapters before 31st January.
Yes,
Please
sir.
do that. Because yeah, it would be totally impossible for you to complete all those chapters in February month only. Please, yeah, in your 24 hours of your time daily, take out somehow, make some timetable, arrange your time, reduce your sleeping time, all those things, all those tactics you apply, and somehow take out 3 hours of sleep, and then manage your time in your weekends as well, right? So your weekends, you have all those, you can take out 10 hours, right? Because 7 hours that is gone in your school. That time as well as your 3 hours. 10 hours in your weekends you can cover. You can cover all those things. But you have to utilize your time very carefully because this is your board exam. Very important stage of your life. This will decide your future aspirations.
Yes, sir. Done.
Yeah. Okay, so now magnitude part we have done. So what is the is it is okay. So then how do we calculate the direction? So how do we know the direction? Direction of magnetic. So before we understand this thing, we have to recall some notations, right? So we already know. What do we know already? We have one notation of directions, that is I, J, and K, right? What is I hat? What is I hat?
X.
Yeah, that is unit vector in x direction. So
Yes, sir.
x direction. J hat is y direction, K is z direction.
Z.
All these are unit vectors. And what is the unit vector?
So, what is the unit?
Yeah, so that we have discussed so many times, and I have asked you so many times, and again you got confused in the answer. You know the answer, but you got confused. So magnitude is one for the unit vector, right?
Yes, sir. Magnitude is one.
So that is the
So
only definition of the unit vector, right? Magnitude.
okay, fine. Yes, sir. A unit vector is a vector with magnitude of 1. I
Yeah,
remember that, sir. I remember
yeah,
that.
yeah, yeah. Yeah. So now the other notation is this dot and this cross notation, right? So this dot represents what is the direction it represents?
So
It
downward.
downward. No, no. So let's say if you have an arrow, right? This is the arrow. This is the tail part of this arrow, right? And let's say this arrow is coming at you. So which part you will see? This part or this part? Yeah. Let's say the arrow is coming at you, not the actual
Hmm.
arrow. Just imagine, right? So what part you will see?
Sir, the tip.
Tip. So tip would be like this, right? Point.
Yes, sir.
So this is coming at you, which means out, right?
Hmm.
So this is outward direction. And let's say the arrow is moving away from, right? So what part you will see? This part, tail part, right? So you will see the
Hmm.
cross part, right? You have those leaves. So in your tail, in the tail of those arrows, some leaves are there, right? So those are in this way, right? You have this leaf and then you have this leaf. So when the arrow is going away from you, so you will see this part, right? So this is inward direction. So in your EMI and all those things, you have seen this kind of direction. So this represents what direction? Yes, this
Inward
represents
direction.
inward direction, right? Yeah. So that is one notation. Yeah, we have to remember these two notations, right? So somewhere I will be using this thing, and somewhere I will be using this k hat. So this dot is what direction? Because inward and outward is k direction, k hat direction. So what is this dot direction? Inward k hat or minus k hat?
So minus k hat.
Minus k hat is into the screen, right?
So k hat.
K hat. So this is k hat, and this is minus k hat, right? So you have this x, y. X, y is in this plane. So whatever I'm writing in the board, in the screen, that is x. So this has x direction and this has y direction. So that is two dimensional. And when I'm coming out of the screen, so right, I'm talking about the direction which is coming out of the screen. So that would be three-dimensional, and this is going into the screen, right? So this is z. So this would be k hat, and this would be minus k hat. So into inward is minus k hat, outward is k hat. So we have to always be very careful with these directions, right? Is it clear?
Yes, sir.
Okay, so now we can talk about the how do we know the direction of magnetic field, right? So how do we calculate the direction? Okay, we talked, gave so much time to this topic. I wanted to at least complete this. Okay, so quickly let us talk about this. So we have two ways to calculate the direction. One is the Maxwell's thumb rule, and the second way is the cross product, right? So whatever is applicable, we will use that thing. So let's say I want to use this Maxwell thumb, right? So I have this let's say this current carrying wire, and the current is going upwards, right? The current is going upwards, and I want to calculate the magnetic field in the right hand direction, right? In the right hand side. In the right hand side, I want to calculate the magnetic field. So I put my thumb in the direction of this current, and I curl my finger at whatever point I am calculating the magnetic field. So what would be the direction if I curl my finger? What would be the direction? Yeah, we have this magnetic field, and I'm curling my finger. So what is the
Yes, sir.
direction? That is, what is the direction?
So those are the thumb indicates the direction where
Thumb
the
is the
electric.
direction of current.
Yes,
Thumb,
sir.
thumb
And
is the,
the rest of the fingers indicate the magnetic field lines,
yeah,
the
the
direction of
direction
the
of the
magnetic
magnetic
field.
field. Direction of the magnet. So if I curl my finger, whatever
Hmm.
direction it is going, so that would be direction of magnetic field. So
Yes,
what
sir.
is the, if I'm calculating the magnetic field at the right hand side, I have this pen, right? And I have put the current is going upwards, right? The current is flowing
Hmm.
like this. I have put my thumb, and now I am calculating the field at this right hand side. At this point, I am calculating. So then what is the direction my curling of fingers pointing out? Inwards or outwards? What is the direction? In the right hand side. Yes.
So the direction of what exactly?
The four fingers, the curling of the fingers. So if I'm curling my finger, right,
Yes, sir.
then what is the direction they are getting in?
So inwards, right?
Inwards, right? Absolutely right. So inwards. So magnetic field would be, let's say,
Inwards.
if I have this current, right? So current is flowing in this way, and I want to calculate the magnetic field. So this is my direction of current. So I put my thumb, right? How do I make? I don't. I'm not expert. I'm not an expert in drawings, right? So you just imagine that I have put my thumb in this direction, and then I'm curling. So the direction would be. So this is how I represent the inward direction, right? Clear? Is it clear?
Yes, sir.
Now you tell me that if I want to calculate if I want to calculate the direction in the right hand side, right? Left hand side. So let's say I want to calculate the magnetic field at Q point. So if you put your thumb in the upward direction, right, and if you curl your finger, then what is the direction that you are getting at Q point in the left hand side? In the left hand side, what is the direction that you are getting? And don't break your hands. Yeah. So what is the direction that you are getting? In the left hand side. In the right hand side, I got the inwards, this cross, right? That is clear to you. In the left hand side, what would be the direction that you will be getting?
Sir, in the left hand side, like if I use my left hand.
No, no. So this is right hand thumb, right?
Yes, sir. I'm thinking that only.
Yeah. So right hand thumb.
Yes, sir.
So won't break your hand, right? So this would be this way, right? This would be this way.
Yes, sir.
So then when you curl your finger, so what is the direction that they are pointing?
Sir, inwards, right?
Inwards. This was the inwards. This
Oh, yes,
was
sir.
this was what? This is what?
Outwards?
Outwards, right? You can check yourself, right? These yeah,
Yes,
what
sir.
have
I
we done?
understand it. But
Understood, right? So
yes,
we have
sir.
this pen, and now let us look at the right hand side. So if we put our thumb in the direction of current, we curl our finger, so that is inwards. Now we have this current carrying wire. Now we are talking about left hand side. So my left is your right, I guess, right?
Yes, sir.
So we are calculating the magnetic field at the left hand side. So we curl our finger. So this is the direction of the magnetic, right? And then we curl our finger. So that is out. Is it calculated?
Yes, sir.
So this would be dot, right? So this is how from Maxwell's right hand thumb rule we get the direction of the magnetic, right? How we should put your thumb, and I should write right in the direction of current, then curl the rest of the fingers the direction in which curled fingers are pointing will be direction of magnet. This is one thing. And then the idea of cross product. So we have this R, right? Remember, we have this theta and we have this dl, right? So the cross product, what does it say? So recall cross product directions. How do we remember that? So remember what was the direction? Do you remember what was the direction of the cross product? Do you remember it? Yeah, how do we calculate the direction in cross product?
Sir, how do we calculate direction or cross product?
Yeah, so let's say you have this A vector, you have this B vector, and this is the angle between them. So how do we calculate the direction of A cross B? Do you remember? Direction, I'm talking about direction. Magnitude part is AB sine theta, right? But I'm talking about this is magnitude of the cross product. What is the direction? Do you remember? Hmm. You have not.
Um, Not completely sure, sir.
Okay, so this I had talked about so many times. This was, do you remember this thing that I
Yes, sir.
said?
Yes, sir. That I remember.
So you had this A vector, you had this B vector. So what I said that put your palm in the direction. So put your palm like this. So your fingertips are in the direction of this A vector, right? Fingertips
Yes,
in the
sir. Using your fingers, right, to like
yeah,
get the
yeah, yeah.
direction.
Yeah, so
Yes,
put your
sir.
fingertips in the direction of A vector. Then this palm should represent the direction of this B vector. So your palm
Yes, sir.
is in the direction of B vector, right? And then you curl your fingers. You curl your fingers in the direction of B, and then your thumb is pointing, whatever direction your thumb is pointing. So that would be A cross B. So A cross B is simply this one. You curl your finger, then your thumb is pointing out to that direction, right? So what would be the, so now this is how we calculate the direction of the cross product. Do you remember it now? We place
Yes, sir.
our fingertips in this direction, and palm is showing the direction of this B vector. and then we curl our fingers. So whatever direction our thumb is pointing out, right? So that is
Hmm.
what direction? Can you tell me that is inward or outward? It
So
should
that is
play
outward.
absolutely correct. So that is outward, right? So that is this absolutely correct. So this would be AB sine theta and this. So outward meaning that that is perpendicular to A, right? And that is
Hmm.
perpendicular to B as well, right? Yeah, and this thing we did in the IJK cross product, if you remember it, right? So now let us understand that how can we. So you remember that from Maxwell's right hand thumb rule, we have got this direction. So from cross product as well, we should get the same direction, right?
Yes, sir.
Because the magnetic field direction is unique, right? Happening. One minute. Okay, so what is the temperature there? Because it's very, very, yeah, cold in here.
Yes, it's a bit cold here also. Today it rained in Bahrain.
Oh, it rained also. On top of that, it rained. That would decrease the temperature as well, right?
Yes, sir.
Yeah, so we have what is the vector notation? Remember dl cross r. So we will put our palm in the direction of dl such that our fingertips is in the direction of dl and our palm in the direction of r vector, right? And then we will curl our finger and then the thumb will point out the direction of the magnetic field, dl cross r. So let us look at this. So what is the direction of dl? This is the direction of dl, right? And where is r vector? That is in the right hand side, right? So you tell me that if you use this cross product, what is the direction that you are getting? What is the direction that you are getting? If you put your palm such a way
Hmm.
that your fingertips is directing towards TL, your palm towards R, then if you curl your fingers, then what is the direction that your thumb is pointing out? Yes, do this and tell me what is the direction that you are getting.
Sir, my
Your thumb, right?
yes, sir, my thumb should point downward, right?
Yeah, that should point downward. That is the correct answer. So did you get that?
Yes, sir.
Yeah. So this is my TL, right?
Hmm.
This is my TL. So I put my fingertips in the direction of DL. And this palm is in the direction of the R vector, which is right hand side, right?
Yes, sir.
And then I curl my finger. So if I curl my finger, what is the direction that I'm getting? Right.
Yes, sir.
So that is it. Is it clear? So I have this thing, right? And if I curl my finger, so that is it clear to you?
Yes, sir.
Okay, so again from this cross product method as well, we will get the direction of this magnetic field. Put this method is what? Put your palm in such a way that your fingertips are in the DL direction and palm in R direction. Curled your fingers in the thumb. Okay. Curl your fingers, leaving your thumb, right? Not the thumb also. Curl your fingers, leaving thumb to the direction thumb is pointing at will be direction of magnet, right? Which is DL cross the. So these are the two ways that we get the direction. So please note it down. And then yeah, and
Yes.
we will quickly we'll quickly understand what is the application, because the purpose of this Biot-Savart's law is to calculate the magnetic field, right? So what is the application of this magnetic field that please note it down, and whenever you have noted it or whenever you want me to scroll down, please.
Yes, sir.
The left hand one you can easily understand from this, right? So let's say we have this DL direction. This is our fingertips, right? So this is pointing at the DL direction. This palm is pointing at left direction. And then when we curl our finger, right? Then when we curl our finger, so what is the direction that we are getting of the thumb? What is the direction?
It's backward.
Backward. So you have you have
Hmm.
this palm, and then you what is the direction that you're getting?
So the direction of the thumb,
Yeah, direction of the thumb. Towards you or away from?
it's away from me.
Away from.
Oh,
Yeah,
so like from my perspective, right?
yeah.
It
So
look.
you do your experiment, right? Not
Yes.
so you yeah, do
Hmm.
your experiment. You have this pen. You put your palm in this way such that your fingertips is pointing towards this DL direction, and
Yes, sir.
your palm is in the left hand side, right? Because you
Hmm.
want to calculate the magnetic field in the left hand side. So and then you curl your palm. So what is the direction your thumb is pointing now?
So towards me.
Towards you, right? Towards you,
Hmm.
which is coming out of the screen. So
Yes, sir.
outwards. And then this one is, yeah, this one is very tough to do because we have to put our fingers. But yeah, so this is going. This one easy to tell. This one is, yeah, somewhat difficult to hold our. Like, yeah.
Yes, sir.
Okay, so but we'll get the same direction. Yeah. So now please note it down, and whenever you want me to scroll down, please Yeah, whenever you want me to scroll down, please.
Yes, sir, done.
Yeah, so this part also.
Wait, sir, can you go up? I forgot to write something. Yes, sir, just the arrow I didn't make.
Oh, yeah. That was just understand, right?
Yes, sir. You can scroll down, sir.
Yeah, noted.
Yes, sir, last two lines just.
Oh, yeah.
Yes, sir, done.
Okay, so now let us understand what is the application of this biosensor, right? But yeah, we have one question, right? Yeah, well, okay, we will do that question in later part. But just remember that this is how we calculate the mind, right? So there's this equation that you have this length, small length element dl, which is placed in, I guess, x direction, and then you want to calculate the magnetic field in y direction. So I guess, yeah, this is some kind of question. I don't remember that, so that we'll do in next question, right? Next class. But yeah, so just just let us just understand what are the application of this Fire-Saver's law, right? So what is the application? So from biosavage, right? The usual shape of the current carrying wire is what? What is the general shape that you see of the current carrying wire? So there can be two scenarios, right? One would be that the wire is a straight wire, and the other one would be that the wire is a circular wire, right? And you will say that, let's say I have this kind of wire, right? But this I can change it into four different straight wires, right? So these are the most two general shapes of the wire, right? Is it clear to you? Yes, is it clear? Yeah, I guess
Just a
not.
second, you repeat the question, sir. Sorry.
No, no, no. So I'm just telling you that the most general shape of the current carrying wire you can see is this straight one or this circular one, right?
Hmm.
This is the most general shape of the wire that you can see in general cases, right?
Yes, sir.
So this biosavage law is very helpful in calculating the magnetic field of straight wires and circular wire. So there are mainly two application, right? Application of biosavage law that is divided in two parts. One is the straight wire, and the other one is the circular. Right. So again, this straight wire that is of two kinds as well. So one is this infinite wire, and the other one is semi-infinite wire. We don't have, yeah, in our part, in our syllabus, we don't have finite wire case, right? So semi-infinite wire. But for the circular wire, we can have three cases. One is that you have a full circular wire, full circle, full circular, full circular. The other kind of wire you can have is semi-circular, yeah, semi-circular wire. And the other one you can have is the arc wire, right? So what is a full circular wire? So you have a wire which is full circular, right? Semicircular wire is you can have this kind of wire, right? And the arc wire is, let's say that you bend some wire in this. This is making some arc of the circle. So these kind of three shapes that you can have, and for the straight wire you can have two cases, right? The finite wire is not in the syllabus, at least for the CBSE point, right? So from Biot-Savart's law, we can calculate the magnetic field of all these five cases, right? So let me just directly write. The proving part we will do for these things, but yeah, so the proof is not needed for infinite wire, semi-infinite wire, right? This part is not there. The proof of this infinite wire we will do using the other law. Yeah, so that is the Ampere circular law. So that part will, but from this Biot-Savart's law, I will directly write that. Let's say first cases are straight wires, and the first one is first we have to note, right? The note is that right. So note is that, let's say if you have this wire, right? You have this wire, and you are calculating the magnetic field at the line of this wire, right? So this is the line of this wire, and you are calculating along the line, right? So can you tell me what is the direction, what would be the direction of displacement and the direction of this dl? What would be theta in this case? What would be theta if we calculate the magnetic field? We are not calculating the magnetic field at this point, at this point, at this point. We're calculating the magnetic field here. What would be the theta for this case?
Sir, it will be theta.
Theta is the direction between I and this displacement. So displacement is
Hmm.
this equal to, right? So that is 0 degree, right?
So Z.
Yeah, so theta may be 0, and if we are calculating at this point, so that would be 180, right? So both the cases are possible. So sine 0 or sine 180 is how much? That is 0, right?
Yes, sir.
So always remember that this part is not needed. I just told you that what is the reason. So just remember that whenever you are calculating the magnetic field at along the line, right? Along the line of direction of current, so that would be how much? That would be 0. So B, let's say this is some A point. So magnetic field at A, that would be 0. Is it clear?
Yes, sir.
This is first thing that we have to remember. Now let me write the result. So first case is infinite wire, right? So this is going this way, this way. You have this infinite wire, and then if you calculate the magnetic field at this distance, perpendicular distance, let's say this is r. So this magnetic field, right? This magnetic field would be simply mu naught and I by 2 pi or r. So that would be the magnet. Is it clear? Oh, I forgot about this. I forgot to tell about this, right? Yes, that I'll talk about. So this would be the magnetic field of a straight wire. Is it clear?
Yes, sir.
And if I calculate the magnetic field and direction, you can calculate, right? Direction would be right hand thumb rule. So we are calculating in the right hand side. So magnetic field would be what? Put your thumb in the direction of current. So magnetic field would be cross, right? Clear?
Yes, sir.
And you have this. So this is infinite wire, and then you have the semi-infinite wire. Semi-infinite means that one end is fixed and the other end is infinite. And then some I current is flowing through it. And then you calculate the magnetic field at the finite end, right? So the perpendicular distance between this. So this, let's say this distance is r. So again, this magnetic field would be mu naught I by 4 pi r. So that would be magnet. Is it clear to you?
Yes, sir.
Okay, and then now I forgot to talk about this mu naught part. So where should I write this? Write this in here. Right? So I should talk about this mu naught. Okay, I will talk about this. Right. Let's make some. Let's make some box. Right. And what is this? So mu naught is permeability of free space, right? And the value of mu naught by 4 pi. So mu naught by 4 pi is 10 to the power minus 7. So value of mu naught is 4 pi into 10 to the power minus 7. And what would be the unit? So unit would be, because we have this, right, because we have this magnetic field, which is mu naught by 4 pi I dl and sine theta by r square. So the unit of mu naught would be how much? That would be Tesla meter square divided by this meter and then this current, which is ampere. So this will cancel. So the unit of this mu naught would be Tesla meter per amp. This would be right. And we also know that this mu naught, what is the significance of this mu naught? So this is telling that the magnetic field is also dependent on the medium, right? So if we have if this system is put in some medium, so in place of mu naught, you will have mu, right? That is the same analogy from the electric. So in electric field, we have this epsilon naught and we have this epsilon. Same analogy. Is it clear?
Yes.
Then please note down these. Okay, so we'll stop at here because you said that you want to prepare for the. Yeah, so this part you have noted. So down. You can note down these portion and then we'll end. That's right. Could be to stop 10 minutes early.
Yes, yes, scroll down. Yes, sir, done.
Okay, so please note down this part as well.